Nice. Did they know where they were exactly? Could they tell you their story? I was like here, you know. Oh, did anything happen there? Did they like clear that out during? They didn't say. Interesting. So I wonder what they would have done. Okay, so knowing this, okay, for everyone, we should know what's that +1 do? Which way does it move it? One to the right or one to the left? Left. What about that -1? Down one. And then that's what you need to know for your family of functions. This is what I was going to do. I didn't do this last hour. They should be okay. You're supposed to know this. All right. Oh, there's the first supposed to from Mr. Samuelis. That was the point of doing your book of functions. We should know that y equals x is a line. We should know x squared is a parabola. Right. We should know an x cubed has this kind of flattening out thing. The domain and range is all real numbers both ways. So x cubed a little different than x squared. We should know that we do have two asymptotes when we have 1 over x. So these are the things that you're supposed to be locking in. We will tackle these more in chapter 2. But we do need to get those asymptotes ideas down. And then the 2 questions I put on your worksheet were just shifted right, left, up, down. That means the asymptotes were as well. Square root function, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. That's why we get that little riser there. But what I was getting to is this. You must know that all exponentials have a horizontal asymptote. Parent function at y equals 0. So new ones, if it's shifted up and down, that's where the new horizontal asymptote is. And then what else should we know? We should, maybe this is going to be more chapter 3. We are not going to ask this on a chapter 1 test. And semester 2 is when that happens. I know we took off greatest integer, semester 2 for cosine, and the logistic function, maybe if I just gave you a picture. Forgot 1? You better know that an absolute value is a v. All right? So what have we reduced this down to? I think 6, 7 things you should know, including a line. You should recognize when I have this equation, this is the picture I can expect. But because I feel like that's not happening with a handful, we still don't have it down. You need to get going. I mean, there's no other way I can say it. We need to get this taken care of. So I have that. Now it's going to be input, output. I'm going to start with -1. There's the left one. Hey, everybody, what's -1 plus 1? I'm getting sick of this question. What is anything to the 0 power? What's the answer? Don't make me crazy. 1. I'm getting all these different answers every single time I ask this question. Oh, by the way, though, what's 1 minus 1? 0. So -1, 0. Let's flash back to that book of functions pictures. That is this coordinate, the 0, 1. The anything to the 0 power equals 1 point. That's where it moved to, right? And that's why I want to identify what makes the exponent 0 there. And then you want to plug in around it, -2 and 0. And then you want to see where's the graph going towards. Okay, what's 0 plus 1? I'm going to plug in 0 first. What's 0 plus 1? 1. 1/4 to the first is 1/4. This always makes me sad. 1/4 minus 1 is 1/4 minus 4/4. That's just -3/4. I did not do calculus there. I did grade school fraction work. All right, 0, that's where the asymptotic behavior is occurring. It's going to be getting closer and closer coming to the right on this side. I can prove it with -2. -2 plus 1 is -1. Oh, this hurts me too to ask this question. What's 1/4 raised to the -1st? We should know this, our exponent rolls. 4. It's a flip. Negative exponents flip. What's 4 minus 1? 3. So we should have been able to plug in to see this action. So it's the exponential, but it's behaving to the asymptote on this side. And guess what we have? A fumble. All right. Turn in your homework. All right. So that's why I expect those coordinates that I had there. Please. I'm so rude. And then when you turn in your homework, hey, those that are online watching this video, just go ahead and take this down, and then during this time that I walk away, just move the video to the future. taping right now as I walk away from the desk. You didn't turn in the other one from this way, did you? Or 2 days ago? Wait, what's going on? Oh, he printed this one. Yeah, okay. That was the only one that you saw that. Yeah, then put this one in there. Right, that was the only one I posted for me, right? That one or two?
I just didn't know if you had to rip it off.
Yeah, they never stapled, so you were worried that, gotcha. Understand. Are you okay, dude?
Yes.
Good. Yeah, I always check in. And you find it weird. Okay, all right, so get your notes out. You don't have your notes out, so you're not doing okay right now. Boom! Look at that, telling the truth. So put your worksheet away. No. Where's your notebooks? Come on. People are waiting online. Yeah, get your notes going. I don't know what fifth hour is doing. No notebooks are up. What are you? Nothing? I can do it? No notes? Yes or no? Just shoulder shrug? No. Here, I'll take those. Just in case I don't want them to fall on the floor, you know? I got it. You do a lot of things. Did I drop there? We're just like, have people left this for president? I think I want to miss them too. I think there's 20 people on this already. Let's see if these holes match up with the holes that I see in this. No, it can't be. And then these two are here. No, Scott's not, right? Yeah. I didn't cross out Scott yet. And then I go. Man. Okay. Oh, I said Ivo's name. Okay. Input, say it. All right, so I do want you to write all this down, but then I'm going to move back up and have you not write down. It's just like pictures. And what we're doing today is what's called piecewise functions. And I want to show you something I stole off the internet just today. And hopefully, you know, that I did a search and it comes up. I'm not stealing something illegal. And I'm not stealing any work, but I did find it interesting. What this is called piecewise functions. And I'll have that up at the top when we show that. Actually, I could put that right here, piecewise functions. And it's not like, I don't know what section this would be called. I think it's part of 1.3, I think, in our book. Or it might be 1.6. I don't care. I give you a worksheet, so it doesn't matter. So here's what a piecewise function is. It's a graph. Here's one example. It's a graph, and I don't know if I could cut off that other one, where it's in pieces. That's why it's called a piecewise function. I will tell you a quick story that'll bore the heck out of you, but this is actually true. I told my last hour it was with text minutes, but it wasn't really. Back in the day, I had a phone. Remember the 9/11 speech? My phone could only make a phone call, and that was it. And I remember I got burned on one of my phone bills because the bill would be like, I don't know how many minutes I got for like $30, but that was it. That's what it started. Actually, I had a cheaper thing where, because I didn't use my phone much, I still had a landline, and this was secondary. Like your cell phone was only for emergency, nothing more. Now it's funny that no one has a landline and everyone has a cell phone now, or the reverse. But I remember I was traveling one month quite a bit, and I had to sell a house. So I had to call my realtor like quite a bit on the road. So my plan was something like $20 for the first, let's say, 100 minutes. Then after that, it was like an exorbitant amount of money per minute. Like any minute after 100, it was like 10 cents. But that adds up. Like it was probably even more than that. That is a piecewise function, my friends. If you could see my hand, if it was $20 for the first 100 minutes, 1 minute used, $20. 2 minutes used, $20. 3 minutes used, $20. Input, say it. And that is what kind of line? Horizontal line for what my price is for this situation for the first 20 minutes. Then after that, it went up like 10. It was something more than 10 cents a minute. I'm just using an example. Then it was 10 cents a minute after that. Now you have a line that has a slope of 0.1. For every 1 minute, you go up 10 cents. Well, I actually got nailed for like a $200 phone bill, and I didn't know what was going on behind the scenes. I didn't really know what a package was. I didn't know what those extra minutes, how catastrophic they were going to be. In addition to the fact there was something about roaming when I was in a different part of the country, the price tripled. Boy, you talk about a whole bunch of different pieces going on there in that function for cost. Mr. Cernowski, I love giving him credit because we hang out a lot. His son wants to be an engineer. He's a senior right now. And he might want to do roller coaster engineering because he's a roller coaster freak. He loves them a lot. So I looked online. I'm like, hey, look at this one. Here is some sort of roller coaster engineer graph. And what the input-output is, the input is time. So over a certain time on this roller coaster ride, here's the height that you are. All right, and then notice there's different things happening at each part. Roller coasters do all these different extravagant things. But I want you to look at this piecewise function and tell me what the first piece looks like. What kind of picture is that? The equation's right down there. It is linear. What's the next one? Quadratic, right? That looks like a quadratic and upside down parabola. What's the next part? Linear. That looks like it's constant. So at some point your roller coaster is just kind of laying flat on, you're not doing any distance change. Hey, what's this next one? A v is a what kind of function? Absolute value. See, this is the recognitions that you should be doing. You could argue on this one, it might be parabolic, it might be exponential, and linear. Okay, but just look at that. All the different pieces, because in the roller coaster, you're at different heights because the things go, you're going all over the place. So that's what a piecewise function is. So what I've given you here is a piecewise function, but I'm not asking you to graph. I'm asking you to evaluate. I pulled this off the internet. I thought this was a great concept to get the idea down of what happens with a piecewise. So here's one thing. This is one function. That's what you need to understand. Oh my gosh, what happened with my writing there? This is one function. It's just defined by three different pieces. Just like the roller coaster, that was one roller coaster ride. But then the heights at certain positions were different functions if you wanted to put them mathematical. Quick question, are you raising your hand? Oh, okay. All right. And then here is what you need to read. This right here is the restricted domain. These are the inputs allowed for each individual piece of this function. Right here, and I guess I'll highlight them. These are the allowed inputs for the three different pieces of this function. That's why it's called piecewise. I'm going to keep using pieces. So we're going to be mean. What number are you, 20? Did we get 22 because of the people, right? Now we just have a bunch of ghosts now in my 5th hour. Yikes. Boo. It is almost Halloween. Oh, I should put my Halloween picture backgrounds. Student number 10. Is that Dana back there? Huh? Oh, 4-8. She's like, no way. It's Noah. Sorry, Noah. You knew it. Hey, what's f of -4 then? Stop. Hammer time. Whoa. All right, where's -4 at? First, second, or third domain piece? Where's it located? First one. That means I have to plug in -4 into the first piece. That's what this is. This is tied to this. I can only graph this for those x values. So that's why I like this. Whoever made this on the internet, great. It gets the idea of using the domain correctly so that we can graph correctly. And of course, what's the answer? 0. All right. And I didn't mean to highlight that, so that's why I wanted to just kind of point at that. Next one. Oh, this is so much fun. Enter 16, 4, 8, 12, 16. Gabriella back there? Are you 16? No, that's not right. 4, 8, 12, 16, 19, 20. Yeah, I guess it is. Hey, thanks for getting me that thing earlier today. Really helped me out, remember? Okay, where do I plug in the 6? First, second, or third part? Third. So that means I have to go to this piece. What's 6 plus 3? Square root of 9. Output. Input, output. Then we'll see how we actually graph these. But it's really what we're doing here is very important. Oh, no. This person got the first hard question. 14. Are they here? Yes. Nice. Matt, right? Yeah. Where do I plug in the -2? First, second, or third piece? According to the domain issues, the domain limitations. Oh, he's right. I didn't want to scare him. Why not the second one?
Because it's
Not equal to. You'll see what happens special with graphing later, but this really does mean I have to plug this into the first one. What do you get for an output value? 4. Good. And then the last one, I'll just do it because it's not that hard. 0 is in the middle domain restriction, so it's plugged into the middle piece. 0 squared minus 3, which is -3. So I love that because I love how that's drawn out like that, like telling you where to go, right? Because that's, I think, the biggest problem with students on this. Then do the next thing. I wish I had these off to the side. Draw this. But as you're drawing this, what's our first picture look like from our family? Linear. What's the second picture look like? It actually is the same thing, which is linear. What do you think the third thing looks like? What's the family of functions probably drawn that one? Square root. And that's what we should know as we look at that. Take a look at whose side. Go to the game. As the students are doing that, I'm just going to show off my new sign, best team in the league. Yeah. Oh, look at that, baby. Best symbol in baseball, too. I don't care what anyone says. How come that's not looking right? There we go. It's like all distorted. Anyone Sox fan in here? Nice. +1 grade level. Anyone a Cub fan? -3 grade levels. Okay. I'm just kidding. Guess I can't do that. Rules. Maybe if it was the 80s, we could. Hey, Matt, did you do anything?
Yeah.
Okay. Adam, your number got called. Okay, now Adam, I'm going to ask you the same kind of. Okay, hopefully you got this, Adam. Like this -3, that's kind of 1.5. That's the only one that's kind of weird. Try to really mark these off specifically. This is through -2 here. So -3, -2, open dot, -1, -2, closed dot. And this is how these happen too, by the way. When you get to the graphing, we got to have open and closed dots. So get this marked in your head. Are you shaking your head? You okay?
No,
You look frustrated. All right, -1, 1. Are you sure?
yeah, good.
All right, open dot and all that other stuff. Here's my first question. Input, say it. So inputs are the X's, the outputs are the Y's. We should be able to answer the same questions from a picture. Because guess what? The picture came from equations, right? I've proven that from the beginning of the year, people understanding that that's what graphing is. So 0, comma, what exists? 0, comma, what? 0, comma, who? 0, comma, where do you see 0, comma? What's the Y coordinate that exists?
0 or -1.
Ooh, so here's 0, comma, and I don't see 0, comma, -1 as a point. You know what I'm saying? 2, 0, comma, 2. Okay, so looking at this as a graphical idea, that's all that's asking, really. It's just asking what's the corresponding Y value for the X value of 0. All right, next one, entry. Oh, 8. Nice. Dana, is this number 2 that you've had to do? No? Okay, for some reason I thought I got you. -4, comma. What does it look like? That's what that means, f of -4. So -4, comma. Well, what Y coordinate exists with -4 as your X input? Okay, here's -4, comma. Where does my finger have to go to match this graph? 1. It has to go up 1. All right, so understanding input output when you have a picture. Oh no, who's going to get this one? This is the tough one. -1 from this piecewise. And then this kind of shows you what you're going to have to do graphically. Nice, Adam. Okay, now, -1, comma. So here's -1 for X, comma. What is the actual output? -2. Nice. Not 1. And that's how you're going to see this stuff graph. Ooh, look at that scary negative down there with that 2. -1, comma, -2. Not 1. That's like a step off. By the way, that's the kind of discontinuity that is. What is this? Jump. Okay, that's what happens. You got to jump from an open and close out to an open or a closed dot to an open, vice versa, whatever, if it happens that way. All right, and then I don't think the last one's very special, f of 3. So f of 3 actually ends up being 3 for my output as well. But it's just putting you in the right spots in the graph where these inputs, outputs go, and then that really dictates how you're going to graph this. All right, I probably had some ambitious things going on here. I'm just going to go to this one. We're just going to do this number 12 here. Okay, so first things first, as you're about to write this down, you're just graphing this one now. So the other two, we were analyzing what were the input outputs. Now the directions are just graph this bad thing here. This nasty, nasty thing. I think someone last hour said, you just made that easy. This looks so tough. And it does. I think students get scared with this big brace and then all these things floating around all over. And really, if you just get this figured out, then all this is right here is the domain that I'm allowed to plug in. These are my inputs. I don't know why that didn't stay. These are my inputs that I'm allowed to plug in for each of the 3, in this case, sections that I had. Okay, so as you're writing this down, I'll select my students. We'll take this one piece at a time. That's a new one, but not here. Lucky number 13. He gone, right?
Yeah.
Oh, we should go tell him. Look at us. This is fun. We're stuck in a loop here. 16. Gabrielle, is that you? She'd yell at those people that left the class. All right. What's the first piece? What is this a picture of? I'll graph. You know what? I'll do something different. I'll graph these in colors. I'll graph this in green. What is that a picture of? That's like line, parabola, like the square root curve. It's a line. Okay, so what am I allowed to plug in? What am I going to have in my chart of values? Like my input, output. What am I allowed to plug in? What is it telling me off to the right here I'm allowed to plug in? 0. Plug in 0. What do you get? And guess what? That is your first point. Or, a better way to say it is probably your last point. Because you can only graph this from left to right all the way up to that position. What else are you going to plug in? We could do this, whatever we want. Let's see how good you are with your fractions. What do you think I would plug in to make my life easy? But 3 is not less than 0. Oh, I thought you were going to say -3 because of your first idea. Right? Wouldn't something with a 3 in it, something that 3 goes into, be the easiest? How many points do you need to make a line, by the way? You only need 2. So I only need 2 in my chart to get this shape. Okay, let's see if what's -3 times 2/3? Do you know what that is then? The 3's cancel, and then you're left with what? -2. I don't know if you said that. What's -2 plus 3? 1. 2 points make a line, or go back and think about your slope. -3, 1. Does that fit the slope correctly? Rise 2, run 3, and it does. But here's how you have to graph it. You cannot go past that 0, 3 value, but this does go forever in the left direction. Because I could have plugged in -6, -9. I could have plugged in forever those other x values. And that's what we need to understand about a piecewise function. We must stop, all right, and not have a whole bunch of graphs running all over each other. There's pieces that stop and then start with another piece. And I'll do the second piece in red just to kind of do something that I highlighted last hour. I think different colors works a little bit better. 4, 8, 9, 10, Noah. What's this middle graph? What? Noah, what you have to understand is that just means f of x equals 3 or y equals 3. What kind of picture is that? A straight line. All lines are straight, but what kind of straight line? Starts with an H. You said it. You beat me. Horizontal line. Can I plug in 0, Noah? Yes or no? But guess what? I am. Okay, and then 0, comma. Well, every y coordinate is going to be 0, comma. It's going to be 3 because it's a horizontal line. What am I going to put, Noah, at 0, 3 though? And it's kind of weird with ignore the green graph for a second. What kind of dot should I put? Because I'm not allowed to plug in 0. It open. But what's special about this, Noah, is it's closed from the previous graph. So overall, it is closed. It's filled in from the green graph. But I'm going to put it there so you know I started there at least. And then guess what? No, I'm going to put 2. By the way, 2 comma. It's a horizontal line. So 2 comma what? 3. What am I going to put yet again at 2 comma 3? It's an open because you're not allowed to plug in 2. But you plug it in so you get what 1.9 comma is. You know, you can't ignore 2. And you can't only graph it for 1 comma. You do have to graph it for these 2, but you must put an open circle on there. And then get everything else by connecting that line because it is a line. All right, and then the last one. 11. That's a no. Nope. That's a. Oh, we should call her. 13. Adam. I feel like you've been picked a lot today. What's this last thing a picture of? It's not Adam? Wait, who's 13? That's another ghost? Oh, I got was off 1 on the rows. Nice. Everyone just saved Adam. Watch it be 9. Oh, for granted. Yeah! Can you believe that? All right, Adam. See, I knew it was going to happen. What's this last thing a picture of? It's a line again. What am I going to plug in right away? You are going to plug in 2. 2 comma. Well, that's nice. What's half of 2, Adam? What's half of 2? Negative. I know I worded it half of, but then I threw the negative on at the end. Okay, so 2 comma. Oh, we definitely have a step off. By the way, open or closed dot there. X greater than or equal to 2. Closed. I can plug that in, so now it's a close. That is a step off. That is a jump discontinuity now at that point. And then you could use slope because you know this is a line, or plug in what we did last hour, which was 4. What's half of 4? Negative, right? So -2, that gets me the down 1 over shape 2. And then this has to go forever because I can keep plugging in numbers greater than 2. So that's why the arrows must be there. No arrows, you're gone. Mr. Samuels is going to get you. Okay, now I'm really going to test this last person on the first question. What's 11? Is that McKenna? Not here? Oh my goodness. McKenna, you got lucky. Good day to miss. Ivo. Who's 7? Ella. Nice. Okay, here we go. Boom. Oh, you know what? I'm going to go to this one. I think one more is good, I think, for time. Oh, no, Ella. I'm going to make you, as you're writing this down, and everyone better listen to Ella here. What's our first piece going to look like? I'll do that in red. What's that a picture of? Line. What's our second piece, which I'll do in green? What's that going to be a picture of? And then what's our third piece, which I'll do in blue again? Whoa. What do you see as the function of those 2 straight lines? What does absolute value always look like? V. So I have a line, a parabola, and a V. Be careful. In your piecewise functions, depending on what the domain is, you may or may not see the parabola or the V. It depends, and we'll have to look at that for the chart. Well done. This is the kind of things you do as a student. You think about this before you go. Boy, there you go again, McKenna. You got a really good day to miss. 4, 8, 12, 16 for Evan. Is that another one? Holy cow. All these people absent. 7? Okay, we're back to Ella. Let's graph that first one. This is fun. What can I plug in, Ella? What number should I put? Okay, let's reword that. What should I plug in for X for the line? Where should I actually start? So again, remember what this means off to the right. These are my restrictions as far as what I can input. Okay, I could plug in 0, but I actually should have started at -2. First of all, let's plug in -2, even though it says I can only plug in less than -2. What do you get for an output when you plug in -2? So -2 times 2, -4. -4 minus 1 is? Good. What kind of dot do I put there, though? That's the question. I'm not allowed to plug in -2. But I did plug in -2 because I need a starting point, and I need to know that that is an open dot there. Good. Negative 2, comma 1, 2, 3, 4, 5. And then I put an open dot down there. How many points do you need to make a line, Ella? Just how many? 2. So I'll plug in something else like negative 3. What's negative 3 times 2 minus 1? Making you guys evaluate, making you stretch out your brains mathematically. So negative 3 times 2 is? Negative 6 minus 1 is? Okay, and then we could also see this as a slope thing if we're not sure. And then I had 5, 7. Sorry, I was screwing that up. So up 2 over 1. Boom. And then that's it. And then notice I do put the arrow because we could have kept going forever. Negative 4, negative 5, negative 6, negative 7. So that arrow must be on that piece there. But it must stop there because that's what I'm allowed to plug in, and that's it. All right, let's go through this horrific calculator student selection thing with all these absences. Evan, no. Evan, no. Ella, come on. I'm going to leave you alone. Who's 9? Adam, come on. How many times have you gone? Let's get to 8. Who's 8? We got Dana. Dana, have you done anything today? Once? Okay, let's go ahead. All right, so Dana, what's that x squared plus 1 again? What's it a picture of? Okay, now, what's that plus 1 do? Because I'm going to think about what this graphs before I put that in. What's the plus 1 do to the family parabola? Up 1, right? Okay, so it goes up 1. So I will have my vertex between these two values from negative 2 to 3. Like the vertex we should know is 0, comma 1. And I am going to graph that because 0 is allowed in my domain. Okay? And then just to get this going here, we are going to plug in negative 2. And we are going to plug in 3. Those are the outer parameters of the domain I'm allowed to plug in. What happens when I plug in negative 2, Dana? So I'm asking input, output. What's negative 2 squared? It's actually 4. What's 4 plus 1? 5. So I'm going to put negative 2, 5. But what kind of dot am I going to put in? Is it open or closed? That's your question for Cat. Tell me now why it's closed and not open. What does this have here for x compared to negative 2? X is greater than or what? Equal to negative 2. That means I'm allowed to plug in negative 2 into this function. That is why it has to be a closed dot. And then the fact that I know this is a parabola and I know that I have my vertex, there's the parabolic shape between those 2 points. And now I plug in 3. What happens when I plug in 3? What's 3 squared? 9 plus 1? All right, and then you get 3 comma 10. 1, 2, 3 comma 10 up here. What kind of dot do I plug in there? Open or closed? Open. And now hopefully you got that locked in your brain. That's why we do open dots there. Then the parabolic shape will look like that connected to that dot. So there it is from negative 2 to 3, including negative 2. There's my parabolic shape. And then last but not least, but we got to get over here. 21, 22. Did I plug that in? Yeah, 22, 21. Dang it, 19. What do we have for 19, 16, 17, 18, 19? Samantha, are you back there? Nice. We did get someone new. What is that blue picture a picture of? Which is a picture and should be a picture of a V. And guess what? I am going to plug in 5 because 5 is in my possibilities. 5 minus 5 is 0. 0 times a half is 0. Negative 2 minus 0 is, everyone? Negative 2. There is my vertex, 3, 4, 5, comma, negative 2 of this V. And I did graph it as a solid dot because 5 is right in there and number greater than 3. But I'm going to plug in 3, Sam, and I'm going to ask you to evaluate on that. Oh, no. What's 3 minus 5, order of operations? But what's the absolute value of negative 2? 2. What's half of 2? Make it simple. 1. Negative 2 minus 1. What's negative 2 minus 1? Boom shakalaka. What kind of dot do I put on that? Open or closed? I plugged in 3 for x. Was I allowed to? Yes or no? It's closed. I was allowed to. 1, 2, 3, comma 1, 2, 3 down. And then there, Sam, is the V, but it stops there because of my limitations. By the way, what should I know 7 comma is right off the bat? Huh? Watch. 3 comma negative 3, V. So 1, 2, 1, 2. What should 7 be? 7 comma what? Oh, he missed it. 3 V, it's like a parabola. There is that symmetry there. We can prove it. 7 minus 5 is 2. Absolute value is still 2. Half of 2 is 1. You do get negative 2 minus 1. So I do have this, and this does go all the way through into forever because I'm allowed to keep plugging in. So the only part of the V that we have is this one, and then this one goes forever there. That's how you got to be careful on going through that sheet. I did purposely pick the kind of functions I did in that worksheet to get your family of functions exercised quite a bit. All right. And that one right now. Sorry, should have done it before I moved my desk.